During the darkest years of the Cold War, when the world stood on the edge of nuclear destruction, the United States faced a terrifying reality. Soviet air defense systems were becoming stronger, faster, and more deadly. Traditional bombers, once symbols of unstoppable power, were now vulnerable. Radar could see farther. Missiles could strike faster, and the balance of power was beginning to shift. The threat was not theoretical, it was immediate and existential. Soviet S-75 and S-125 surface-to-air missile systems had already proven their lethality by shooting down American aircraft over Vietnam and elsewhere. Intelligence reports painted an even grimmer picture. Next-generation Soviet radars were being deployed across Eastern Europe and Central Asia, creating an impenetrable web of detection. Every flight path was monitored. Every penetration attempt was recorded. The skies were no longer free. American military strategists faced a brutal calculation. In the event of war, bomber crews would be flying suicide missions. Penetration rates were estimated at less than 30% against the most heavily defended targets. Entire squadrons could be wiped out before delivering their payloads. The doctrine of nuclear deterrence, the very foundation of American defense strategy, was crumbling. If bombers couldn't reach their targets, could the United States credibly threaten retaliation? And if retaliation was no longer certain, what would stop Soviet aggression? To survive this new battlefield, America needed something revolutionary. Not an upgrade, not an improvement, but a completely invisible weapon. In the deepest levels of secrecy, a project was born, one so classified that even many within the military had no idea it existed. Its mission was simple in words, but nearly impossible in execution. Create a bomber that enemy radar could not see, could not track, and could not stop. The Pentagon assigned the project a bland, unremarkable coding name, designed to deflect attention: Advanced Technology Bomber, or ATB. Budget documents listed it under generic research categories. Congressional oversight was kept to a minimum, with only a handful of senior members briefed on its true purpose. Even within the Air Force, knowledge was compartmentalized. Pilots training for future stealth missions had no idea what aircraft they would eventually fly. Ground crews prepared facilities for an aircraft they had never seen. The program existed in shadows. Within shadows, engineers at Northrop began working on a radical idea known as the flying wing. Unlike traditional aircraft, this design had no tail, no vertical stabilizers, and no obvious shape for radar to reflect. Every angle, every curve, every surface was carefully calculated to scatter radar waves away from their source. This was not just aircraft design, it was physics, mathematics, and secrecy combined. The flying wing concept itself was not new. German engineers had experimented with similar designs during World War II. Northrop's own founder, Jack Northrop, had been obsessed with the concept for decades, believing it represented the purest, most efficient form of flight. But what was once pursued for aerodynamic efficiency was now being weaponized for invisibility. The smooth, blended surfaces that reduced drag also happened to minimize radar reflection. Form followed function in ways no one had originally anticipated. Yet, translating theory into reality proved almost impossibly difficult. Traditional aircraft are stable because their tails provide natural balance. Remove the tail, and the aircraft becomes aerodynamically unstable, constantly wanting to pitch, roll, or yaw out of control. Human pilots couldn't react fast enough to correct these instabilities. The solution required cutting-edge fly-by-wire computer systems that made thousands of tiny adjustments per second, keeping the bomber stable while allowing it to remain invisible. The aircraft wasn't just flown, it was constantly calculated into existence by onboard computers. The materials used on the aircraft were just as revolutionary as its shape. Special radar-absorbing coatings were developed, capable of swallowing radar signals before they could return to enemy screens. Even the smallest panel gaps in engine intakes were redesigned to eliminate detection. Nothing about this aircraft was accidental. These radar-absorbent materials, or RAM, represented breakthroughs in chemistry and material science. Traditional aircraft are built from aluminum and titanium materials, chosen for their strength and weight, but these metals are also highly reflective to radar. The B-2's skin incorporated carbon fiber composites, specialized polymers, and classified materials that could absorb electromagnetic radiation across multiple frequencies. The coatings had to withstand extreme temperatures, high-speed flight, and constant stress without cracking or peeling. Each panel was precisely manufactured to tolerances measured in thousandths of an inch. Even the engines posed unique challenges. Jet engines are inherently hot, and heat creates infrared signatures that missiles can track. The B-2's engines were buried deep within the wing, with exhaust vented through flat, cooled nozzles on the upper surface. This configuration minimized both radar and infrared detection, but it also created enormous engineering complexities. Airflow had to be carefully managed to prevent the engines from overheating or losing power. Every duct, every vent, every opening was shaped to avoid creating radar reflections. Secrecy surrounded every stage of development. Workers entered facilities through intense security checks. Parts were built in separate locations, so no single team could understand the whole aircraft. Conversations were limited, documents were destroyed. The bomber was never referred to by name. To the outside world, it did not exist. Manufacturing took place at Northrop's facility in Pico Rivera, California, and later at Air Force Plant 42 in Palmdale, where final assembly occurred inside specially constructed hangars. These buildings were surrounded by security fences, patrolled by armed guards, and monitored by surveillance systems. Satellite imagery of the area was carefully controlled. Commercial aircraft were prohibited from flying overhead. Even the most routine deliveries required extensive background checks and security clearances. Workers lived double lives. They couldn't tell their families what they were building. They couldn't discuss their work with colleagues outside their specific team. Many didn't even know they were working on a bomber. They thought they were developing components for satellites or experimental research aircraft. The psychological toll was significant. People worked on the most advanced military project in history, but they had no one to share it with. No way to celebrate their achievements. No recognition beyond internal acknowledgement. The cost of this secrecy and innovation was enormous. As billions of dollars poured into the project, critics questioned whether such a machine was worth the price. But behind closed doors, military planners knew the truth. If war ever came, this aircraft would be the first to fly and the last to be seen. Initial cost estimates proved wildly optimistic. What was projected as a fleet of over 100 aircraft eventually shrank to just 21 operational bombers. Each B-2 cost approximately $2 billion, making it, pound for pound, the most expensive aircraft ever built. Critics argued that the same money could fund entire fleets of conventional bombers, dozens of fighter squadrons, or upgraded missile systems. Congressional debates grew heated. Budget committees demanded justification. The Cold War was ending. Did America still need such an expensive weapon? But those with access to classified intelligence understood what the public could not. The Soviet Union might be collapsing, but regional threats were emerging. Rogue nations were developing weapons of mass destruction. Terrorist organizations were growing more sophisticated. The world wasn't becoming safer, it was becoming more unpredictable. And in an unpredictable world, the ability to strike without warning, without detection, without risk, was invaluable. When the B-2 stealth bomber was finally revealed to the public in 1988, it shocked the world. Its alien-like shape looked more like science fiction than reality. But this was no concept. It was fully operational, fully armed, and capable of striking anywhere on Earth without warning. The unveiling ceremony at Air Force Plant 42 was carefully choreographed. As the hangar doors slowly opened, floodlights illuminated the aircraft's charcoal gray surface. Journalists gasped. Military analysts struggled to comprehend what they were seeing. The bomber had no traditional fuselage, no protruding tail, no obvious cockpit. It looked impossibly flat, impossibly smooth, like a manta ray frozen in flight. The shape defied conventional understanding of what an aircraft should look like. Media coverage was immediate and global. Soviet military officials dismissed it as propaganda, claiming no aircraft could truly be invisible to radar. But their internal assessments told a different story. Intelligence agencies scrambled to understand the technology. Radar manufacturers tried to calculate detection ranges. Air defense commanders realized their systems might be obsolete before they were even fully deployed. In combat, the B-2 proved its value. Flying long missions deep into enemy territory, it bypassed the most advanced air defense systems without being detected. One aircraft could do the work of dozens silent, invisible, precise. Its first combat deployment came during Operation Allied Force in 1999, the NATO bombing campaign against Serbian forces in Kosovo. B-2 South flew non-stop missions from Whiteman Air Force Base in Missouri, refueling multiple times over the Atlantic, striking targets in the Balkans, and returning home round trips exceeding 30 hours. Serbian air defenses, which had successfully shot down an F-117 stealth fighter, never detected the B-2S. The bomber struck command centers, ammunition depots, and strategic bridges, with precision-guided munitions, crippling Serbian military operations. The aircraft's capabilities were further demonstrated during operations in Afghanistan and Iraq. In the opening hours of Operation Enduring Freedom, B-2 South struck Taliban and Al-Qaeda targets across Afghanistan, flying from Diego Garcia in the Indian Ocean. In Iraq, they destroyed hardened bunkers, communications facilities, and leadership compounds. Each mission demonstrated the same pattern: complete surprise, surgical precision, zero losses. The true power of the B-2 was not just its weapons, but the fear it created. Enemies never knew when it was coming, or if it was already there. This psychological dimension proved as valuable as the physical destruction the aircraft delivered. Enemy commanders couldn't sleep knowing that at any moment, without any warning, a B-2 could appear overhead and destroy their headquarters. Air defense operators spent sleepless nights staring at radar screens, searching for signatures that would never appear. The mere existence of the B-2 forced adversaries to disperse their forces, bury their command centers deeper, and waste resources on defensive measures that might never work. Military strategists call this deterrence by uncertainty. Traditional deterrence relies on visible shows of force aircraft, carriers, missile silos, troop deployments, but the B-2 represented a different kind of deterrence. The knowledge that retaliation could come at any time, from any direction, without warning. It was a weapon that worked even when it wasn't flying. Even today, much about the B-2 remains classified. Its exact capabilities, its weaknesses, and its future missions are still hidden behind layers of secrecy. As newer bombers emerge, the B-2 stands as a reminder of a time when survival demanded invisibility. The fleet continues to operate from Whiteman Air Force Base, with each aircraft maintained in climate-controlled hangars to protect its delicate radar-absorbent coating. Maintenance is extraordinarily complex and expensive, with each hour of flight requiring approximately 50 hours of maintenance. Specialized teams inspect every surface, reapply coatings, and verify system integrity. The aircraft's classified systems require technicians with top-secret clearances, and certain areas of the bomber remain off-limits, even to experienced maintenance crews. New challenges have emerged. As radar technology advances, so must stealth technology. The B-2's design, revolutionary in the 1980s, must be continuously updated to counter modern threats. Classified upgrades have enhanced its defensive systems, updated its avionics, and improved its weapons delivery capabilities. But the fundamental question remains: can stealth technology stay ahead of detection technology indefinitely? The Air Force is already developing the B-2's successor, the B-21 Raider, incorporating lessons learned from decades of stealth operations. But the B-2's legacy is secure. It proved that invisibility was possible, that radar could be defeated, and that strategic bombing could survive in the modern age. It was not just a bomber. It was a message. In modern warfare, what cannot be seen cannot be stopped.